Today we're going to start dilations. If you look at the picture, you have different sizes of spaceships. As it goes along, the height of the spaceship increases, and it does that in a uniform way. And if you were to bring these two lines together, they create your center of dilation. Every dilation has a fixed point called the center of dilation. It's located where the lines connecting corresponding parts of the figures intersect. So I could actually make a triangle out of that, out of each one of those. Those could be different size triangles, starting with the smallest, then going up to another one, and just all the way till I got to the biggest one. Okay, but it all has the same center of dilation. All right, triangle RST prime is a dilation of triangle RST. Point C is the center of dilation. So here's triangle RST. Here's RST prime. If I were to draw a line from R prime to R, T prime to T, S prime to S, and if I were to just follow that same path, they all meet at the same point. And that is our center of dilation. Dilations do not change the orientation of the figure, so it's not going to change, it's not going to rotate or anything. It's going to stay the same direction. So if we were going to identify the center of dilation here in example 1, we just need to follow these dotted lines down to this point. That is the center of dilation. Okay, this is the COD, the center of dilation. Here we have some pentagons. You connect all the, and then you have the bigger one outside. We draw lines to the corners. They all meet at the same point at the center of dilation. Guys, that is not Call of Duty. It is center of dilation. All right, locate the center of dilation by connecting the corresponding vertices. So if I'm going to do this, I'm going to take D and go to D prime. So I'm going to try to make it as straight as possible. Try. Oh, that's not very straight. If I follow those same points, or follow those lines, I should all go to the origin. So connecting each point to itself in the corresponding shape, and then following it to a single point, got me to the origin, finding my center of dilation. Okay, on the next page. Two types of dilations. Because dilation makes a figure larger or smaller, there's two types. First type is called enlargement. And the second is reduction. So enlargement makes things bigger, and a reduction makes things smaller. Remember that we always start at the pre-image and end up at the image. So the pre-image is the older original, and the image is the new. The image labeled with the prime marks, or the prime marks, the apostrophes. Well, the question will tell you which shape is the dilation. Sometimes it's helpful to label each shape as new or old, or pre-image and image. So, on these next two examples, label each dilation as an enlargement or reduction. So, looking at these, which one is the pre-image or the old or original? So I'm looking at it. That's A prime. So the big one is the old, and the little one is the new. So I can say I went from the old to the new. So I went from a bigger one to a smaller one. Makes that a reduction. Okay, number two, triangle DEF is a dilation of triangle ABC. It says that this one is a dilation of this one. So this is the old, and this is the new. So I went from smaller to bigger, so that is an enlargement. Okay, moving to number three, parallelogram PQRS was dilated to HIJK. So it was dilated from this one to this. So this is our old, this is our new. So big to little is a reduction. All right, is it a dilation? Sometimes two figures may look like a dilation, but they're really not. But the corresponding side lengths on dilations are proportional. Okay, which means that the figures are similar. We've already dealt with proportional and similar figures once this year. To determine if it is truly a dilation, we find the ratio for each set of corresponding sides. If all the ratios are equal, then it is a dilation. Okay, so we find the ratio for each set of corresponding, and all of the ratios are equal. Okay, they all have to be equal. So if it has a triangle, that's three ratios. They all three must be equal. If it's an octagon, that's 8. They must all be equal. Although the ratios may equal for two sets of sides, we must make sure it works for all sets of corresponding sides. Always put the image over the pre-image. So to set up the ratio, you're going to put the new over the old. Okay, new, nice little mark. Okay. All right, so let's look at a couple examples. Determine if each set of figures are dilations. Justify your answer. Diagrams may not be to scale. All right, so it has given us the values for all three sides from both triangles. So we need to figure out if it is a dilation. So to do this properly, it should be orientated the right way. So we should be able to match corresponding sides easily. AC, BC to BC, BA, BA, and CA and CA. So we're going to set up our proportions. All right, we're going to do what we said, new over old. Here is our new, here is our old. So let's do BC first. That is 30.8 over 44. All right, use your calculator, plug in 30.8 divided by 44, and you should get 0.7. Now we're going to do the next one. 14.5 over 29. And we're also going to do 35 over 50. All right, so the next one, 14.5 over 29. Plug that in, you get 0.5. Plug the next one in, you get 0.7. So, are all three equal? No. This one here is not equal to the other, so this is not a dilation. Okay. All right, number 2. Quadrilateral MNPQ has side lengths of 15 millimeters, 24 millimeters, 21 millimeters, and 18 millimeters. Quadrilateral MNPQ has side lengths of 5, 8, 7, and 4 millimeters. So we need to figure out. So this is our new, this is our old. So let's put the new one's numbers on top. So I should have 5 over, 8 over, 7 over, and 4 over. They're in the same order. 15, 24, 21, and 18. 5 over 15, that's 1/3, 1/3, 1/3, 2/9. Are they all equal? No, this one is not. So not a dilation. Okay, going on to number 3. We have two triangles here. We only have 2 sides that we can measure. We can measure AC on both and CB on both. We do this by counting the squares. 1, 2, 3, 4, so that's 4. 1, 2, 3, 4, 5, 6, so that's 6. That one's 2, and this one's 3. Alright, so we're going to do, this is the new, this is the old, so that's 4 over 2, and 6 over 3. They both equal 2. This is being a right triangle, since 2 sides are proportional. 2 sides of a right triangle are proportional. That makes their third side proportional. So this is a dilation. All right, 4. Spin this a little bit. All right, so we have our old, our new. We're going to do new over old. 4 over 12, 3.6 over 9. And being that these are rectangles, means two sides are the same. So that would be 12, and this is 9. There's no need to do 4 times. We just do 1 of each. So if I put 4 into 12, I get 1/3. 3.6 to 9 is 2 over 5. They are not equal, so not a dilation. Okay. Ratios are not equal. Okay, so for it to be a dilation, your ratios must be equal. If they are, one or more are not equal, it is not a dilation. Okay, moving on, last page. Now this video is a little long, but we got to get through it. All right, using coordinates to determine if it is a dilation. Sometimes we can't count the side length of a figure of the coordinate plane because the sides do not follow the grid lines. Okay, instead, we find the ratio using the x or y coordinates of the pre-image and image just like before. If the ratios are all equal, then it is. So what is it? What's it saying right here? It's saying sometimes these triangles aren't turned where you can measure the sides very easily. You count those squares to measure those. You can count it on this side. Count that side because it goes up and down. It's vertical with it. But you can't count the other two. But what you can do is use the coordinates. So you're going to set the coordinates of the new over the coordinates of the old. So let's look at this first one. So I'm going to do A prime over A. And I only have to do one of them. So A, I've got A prime, I can use the X or the Y. I'm just going to use the X. A prime is at 4. Original A is at 8. That reduces to 1/2, or 0.5. B prime over B. B prime is at 4. And B is at 8. That is 1/2 again. C prime over C. C is at 1. Or excuse me, C prime is at 1. And C is at 2. And that is 1/2. So this is a dilation. Because all ratios are equal. All right, number 2. On a coordinate plane, triangle UVW has coordinates at these points. Triangle UVW prime has these coordinates. So here's my new. I'm going to do U prime over U, V prime over V, W prime over W. Okay, so I'm just going to use my x's. That is, so U prime is 15, U is 20. V prime is 6, V is 8. W prime is -18, and W is -24. All right, let's reduce. 15 over 20, that is 3 over 4. 2 goes in 3, so that's 3 over 4. 6 goes into both of those. 3 and 6. Oh, excuse me. 6 goes into those 3 and 4 times. So you get positive 3/4 for each. That's the same ratio for all. Therefore, it is a dilation. Excuse me. Number 3. Almost done, guys. All right, we're going to do the same thing here. We're going to use the points. Use X or Y. Okay, it looks like the bigger triangle is the prime, the smaller one is the old. So A prime over A, B prime over B, and C prime over C. So start with A. I'm just going to let's do the Y's this time. So I go up. Y is 1, 2, 3, 4. A is at 1, 2. B prime. B prime is at 1, 2. B is at 1. C prime is at 4, -4. And C is at -2. So 4 over 2 is 2. 2 over 1 is 2. -4 over -2 is 2. All ratios are equal. Therefore, it is a dilation. Okay, last one. We're going to use X prime over X, Y prime over Y, Z prime over Z. All right, we'll go back to X's this time. X prime is at -1. X is at -1. Y prime, 1, 2, -1. Excuse me, -2. Y is at -4. Okay, and then Z, we have at Z prime is at 0 and Z is at 1. So, all right. This equals 1. This equals 1/2. And this one you can't divide. This just equals 0, so we don't really count it. But these two are different. So, not a dilation. All right, that concludes your notes. We're going to work on the dilations worksheet for the remainder of the period. Um, Number 1, just define dilations on your notes. 2, determine if each one's an enlargement or reduction. 4 and 5, use a ruler to find the center of dilation, COD. And then turning on the next page of the worksheet, you have set up the ratio to determine if each is a dilation. So for the last 4, you're doing exactly what we've been doing on the last 2 pages of notes. On 6, 6 and 9, you can just count the sides, measurements of the sides. And 7 and 8, you need to use coordinates. It even says to use the coordinates on 7 and 8. So be sure and set those ratios up with the coordinates. All right, good luck, guys. I will be back tomorrow.